orange juice soup.
What I'm going to talk about is the breeding program I do. As we've talked before, and also David Tarpey talked before about when you do breeding, you kind of narrow the gene pool, and honeybees are very sensitive to inbreeding. We talked about the mating process. The whole strategy is outcrossing and genetic diversity, so it's a little bit of a balancing act. And for me, the breeding program, I started this early 80s, and I think the real beauty of it is the simplicity of it. That's given its longevity. So I'm going to run through this with you. Harry Laidlaw and Rob Page wrote this breeding theory based on working with a population. It's dynamic, it's flexible, as long as you maintain enough genetic diversity within that population. And this was a bit new. I mean, beekeepers over time have always you take the general population and pull out the best stock. This is just tightening it up a little bit more. Whereas before that, we did inbred systems where you have inbred lines and cross those, and they're a lot more difficult to maintain, and you have kind of an end product in that. So this is working with a population, and the goal is just kind of to select over time and increase the consistency, the frequency of those traits that you want in your gene pool. Mostly looking at kind of general traits. You want just fitness, productivity, things like that. So basically maintaining a population and just selecting for desirable traits in the population over time. So the theoretical model behind this is kind of based on three different aspects: random selection, queen supersedure, and a top cross. Random selection is just within this population, and I've chosen, for my purposes, I've chosen to work with Carnolian honeybees. So establish a population. I started with about 50, 60 different queen mothers, collecting Carnolian queens from all over the US and Canada. And then you established a test population, which is basically just raising a few daughters of each of these mothers, so you have a nice big population of colonies to select from. And from those, select the top third of those, and those are your breeders for the next season. And then you just keep repeating that kind of a cycle. In this theoretical model, what I described to you is pretty much random selection. If you start with a smaller, say you have 20 colonies or a smaller number of colonies, you'd probably want to take a daughter, at least select a daughter from each of those mothers, just so you try to maintain the integrity of that gene pool a little bit better. You can do something called a top cross. That's if you have a really superior queen, say she shows more resistance to varroa, something like that. You can take her and mate her to the pool of drones from the population you've selected. This can be a little risky. You could do this maybe 1 or 2 years, but eventually you're really going to narrow the gene pool. So there's kind of choices in looking at your population size. What we initially did is collect stock from all over the US and Canada. And a lot of this was pretty mixed up, so I'm just kind of pulling out the darker queens, Carnolian-like queens, and back crossing that a couple generations to try to get a more Carnolian-like bee. So we established a test population. From those, I picked out 30, 50 of those queens. Made daughter queens, take 5 or 10 out of those, and you have this test population. And then from those, you select out the top section of those. So, and then you just repeat that cycle every year. That's kind of a quick summary of it. I established this in the early 80s, and our focus was mostly queen production for the industry. We raised about 5,000 queens a year, which is really small for the US commercial production. Most of the queen producers are doing 20 to up to 500,000 queens per operation. And this was moved into Ohio State University. It's gone through a couple different universities, and then to University of California, Davis, and now currently Washington State University. When I went into the university system, I focused more on the breeding stock, supplying breeding stock to the commercial producers rather than doing the production stock. So a little bit more time to focus on that a little bit better. More recently, we've imported germplasm, basically just bringing in semen from some of the original range of Carniolans, Slovenia and Germany. Well, Germany, they're not native there, but they have a good breeding program working with Carnica. So, and that was just to kind of expand the gene pool of the population, given its time frame. I do this with instrumental insemination. I control the breeding, so I'm raising that test population, inseminating. So I'm taking the drones from, I have my 50 test colonies, so I'm raising daughters off of those, but I'm also taking drones off of those and mixing the drones from all those colonies to mate back to those virgin queens. So it is a type of inbred system, but as long as my gene pool is large enough, and you're always looking at the brood viability, have a guarantee that you have a big enough gene pool like that, so it's managed itself. You could also do this. I realize a lot of you won't be doing instrumental insemination. This is just to control the breeding of the pool. You could do isolated mating. This is very common, for example, with the Carnica program in Germany. They have isolated mating stations where they saturate the areas. So you can also work with that. I think this is the most difficult part of the whole program, is the drone production. You want large number of drones from the colonies you select, and to take those to maturity, you need strong, healthy colonies. Given the chemical residues, the pathogen loads in colonies we now have to face today as part of what's in the system, this can be a tall order. So I pay a lot of attention to drone production. I really push it early spring, and as late August, as my season starts ending, the row mites obviously build up quite a bit, so you have to take care with that. We're in our 35th generation, which is pretty exciting. And really, the beauty of this is the simplicity of the selection process. And I'll go through that with you. The basic goal is to just produce a productive Carniolan bee. I chose Carniolan mostly because at the time, most of the queen producers would raise Italian stock, and they had a lot of difficulty maintaining Carniolans because the majority of the drones in the area were Italian, so they would outcross and you'd get a mix of those two different subspecies. So I decided to concentrate on the Carniolans. I want a productive bee. I also want a gentle bee, a nice temperament, and something very winter hardy. So you're also looking at different pathogens as these change. For example, we in the late mid-80s we got tracheal mites, so that was a big thing to start looking at to the selection criteria. And over time, you deal with these different things. Varroa, this is a much more difficult pest to deal with, but you can do selection for some things to have a lesser incidence of that, less severity of the pathogens. If you keep the varroa mites at a threshold level where you don't see a lot of these pathogens being the symptoms of them, that's really what the goal is. And of course, Nosema cerana is fairly new to us, so that was a new issue. Just with a breeding program, you want to be flexible. It's dynamic. Things are changing all the time, not just the environment, but the pathogen loads, the different things they're exposed to. So these things are kind of ongoing. Again, the basic thing here is you're maintaining selection pressure on this population over time, and that's just kind of, you're trying to enhance the natural selection. You're trying to enhance whatever the bees are doing. And skew them toward more productivity, but at the same time more uniformity in that. Genetic diversity is really important. We've talked about that quite a bit. It increases general fitness. You'll get more, not only the inbreeding problems, but you just get loss of vigor if you don't have a nice, good gene pool. So the selection method I use is very simple. You're selecting several traits simultaneously over time, and I'll go through that with you. We evaluate them, select them, and then just propagate the bees. So this is kind of my three-step program. I do what I call pre-selection. Once the queens are established, you kind of go through there and you look for just general characteristics. You look for uniformity, the brood patterns, temperament, how they build up. And then over time, if you may not get a honey flow every year, but if you can evaluate them for honey production on those years that you do get a good flow. And then overwintering ability. Wintering, I think for me, is probably the best selection tool. It just takes out the more susceptible. If they've got issues with nosema or whatever, just general things like that, tracheomites or something, they'll not survive the winter very well, or they'll start dwindling down. So you look for those behaviors. And then once you do the kind of general selection, then I fine-tune it, and we do tests take that, and you do a cut there, you eliminate most of the colonies. So then you take those that you have selected for just general productivity and do more specific testing, like hygienic testing, something that will give them a little bit more advantage toward dealing with Varroa. So that's kind of the overall program, how it works. So again, this is all your selection is based on colony performance. And these things are changing all the time. So once I establish that test population, I've got my 30, 50 breeders, make daughters off of those and just put them out there. Those are inseminated to that same pool of the top 50. Set up yards out there. And then you're just looking for general performance. You just run through these colonies. The queens are all the same age. They're in the same environment. If you have them in different yards, you score the yard. You may have different environmental conditions. Maybe this yard was a little bit more productive. Maybe there was more resources or food. So I have a rating of that yard, a ranking, and then you compare to a different ranking with a different yard. Just taking the top performing colonies off of that. My scale, I've changed this. I just give these different traits a scale of 1 to 5. I've kind of trimmed that down. Now we go 1 to 3. There's more uniformity in it. And you're always looking for incidence of disease, and you can give that a negative point value, or you can just eliminate the colony depending on what it is and the severity. And from those we choose the top colonies. So the pre-selection is basically, I have these new queens set up. They're in a single deeps at this time, and we just kind of go through and pick several traits. What's important? Brood viability is always going to be a major criteria. It just means I can maintain the integrity of that population, really important. Temperament. Can I go through those colonies, and are they calm and gentle to work with? Are they runny or flighty? That's always and you're looking at colony buildup. Starting these queens all about the same population. Is this 4 frames of bees, 6 frames of bees? How's the brood pattern? How many frames of brood? So you can kind of give it a score, just a simple number, instead of having like checks and minuses on the lids, and the lids get changed around and like that. You need some kind of a system that you can just add these traits and quantify the differences. So again, I'm looking for nice brood pattern, and it's not like I'm making a square and counting the skips. You're just kind of scanning a couple of frames. Okay, this is a 4, this is a 3, whatever that is. Temperament, if one's a little bit flighty, she's going to get a lower score. And looking just at those basic traits. The performance is later in the season. If you got a honey crop, we do a weight gain test. And there's studies showing that weight gain over the short term correlates to the whole season. So we weigh the colonies, and this is pretty subjective sometimes. You might have a colony that's been collected a little bit more moisture, so you're looking at the gain over that short term. Just weigh the whole colony as it is, and then compare those over time. And then wintering, you're just looking at how they survive the winter, and that's really coming out of spring. And we do a quick frame count. Is it how many frames of bees are covered in the frames coming out of winter, how fast are they building up? That's for your last. And then from that, I look at the scores, and I'll take the top half of that, and then from those, we'll start looking at hygienic behavior. We do this freeze-kill brood test, where we take a patch of a brood and we pour liquid nitrogen in there to kill the brood, and then the bees will detect something's wrong with the brood and they will clean it out. And that's compared to if you have an infested brood, you could have a disease in there or varroa mites in there, whatever the issue is. So how fast they clean that out will correlate to how well they deal with pests and diseases in the brood, which is where most of the problems occur. So then we give those a score, and usually I'll take a cut from that. I don't use this, not all the breeders have to be hygienic, and that's something that if I have some really good breeders marking really productive, I'll just try to I know which ones are hygienic, and I'll take a higher percentage of drones from those colonies and put that into my gene pool to try to increase the frequency of that over time. So that seems to help. We are always looking for, every time you're in those colonies, you're kind of monitoring what's going on. I use a screen bottom board where I can do look at the mite fall, the just natural mite fall over time. Always have a kind of a fork, uncapping fork. You're looking at always checking the drone brood because I'm pushing the drones. I need those drones. They're really essential for the program, mating the queens. So you're always looking for these particular traits. So then you rank those top performers. So that group of queens, it can be 20, 30, it'll vary year to year what I use. Usually I start at the top, graft off of the top scoring colony and graft off of those until the season ends. How far I can go down, usually it's about 20, 30 colonies. And I'll also be taking drones from all those colonies. We'll put them in one location, and these are my breeders, so I'll be taking both raising virgins off of those and taking drones off of those at the same time. So it is a closed system. And it is a type of inbred system, but as long as you have a big enough gene pool, and I'm always looking around, anyone who's advertising or has Carnolian bees, I'll set up a yard, I'll buy some of those, set up a yard, and look at them, test them. The ones that I like, I'll take drones from those and throw it into the gene pool. But you have to be really careful about that, because in doing that, sometimes you can bring in unwanted things, unknown things, dilute out what you've done the selection for. For example, I had one of my major customers, he had this really super queen, she was really good, and so I got some dollars from that, used the drones from that, but all of a sudden I have a little outbreak of chalk brood coming up. So you have to kind of balance those things and decide, you know, the genetic diversity is really important, but there's a cost with that at the same time. And it's really about just maintaining that selection pressure on that population over time. If you get too relaxed, too comfortable with that, you kind of take a step back. It's a very sloppy program. It takes about 5 minutes a colony to go through the pre-selection process. And each of those, you don't put a major bit of time in there, but you're always kind of looking at them, looking for differences. There's always a couple of favorites that stick out. There's always some that are disappointing. But that's good. That means I have that diversity within my population. So you're just looking to keep slowly improving that over time. And the resistance to pests and diseases, this is always something you're looking for. I'll never tell you, I can't tell you right now the bees are resistant to varroa, but I think they have a little bit more edge than average against the pests and diseases, just because we try to eliminate that at every step of the way. But again, you need the influence, you need the varroa, you need the different pathogen loads so the bees can learn how to deal with that too. So it's important that they're in the population as well. We partner very closely with the California queen producers. they have the capability of mass producing queens. And they're all very good businessmen. I charge them a lot of money for these queens, and if they're not happy, I learn very quickly about that. And you do a little dance, and okay, I'll send you something else. But they're very good at that. Queen production, they do major queen production in California. They're supplying the honey producers, the pollinators. They're supplying package bees we have a new huge growth of hobby beekeepers in the country since the publicity of colony collapse disorder. That's really raised a lot. And you want to give them a gentle bee, a fun bee to work with. I like the production strategy of the Carnolians. They seem more in tune to the environment. They kind of shut down when resources are not good and build up really fast in the spring, winter well. So I have a real bias toward that particular bee for sure. These are some shots from the commercial producers doing the production. I like this picture here because it's 3 guys grafting. Mostly this is women. They seem to have more dexterity with really fine work like that. But these 3, this is Park, working with those, and just California producers. Mating nooks again. Where's this one? More shots of just the mating nooks. Again, what you're looking for is this really nice brood pattern. These are outcrossed with whatever's in the area. They do try some drone saturation, but they're pretty well concentrated, so you get a little mix of stuff of the subspecies. These are some shots of the mating apiaries. These are the little styrofoam boxes, very similar to what you guys have here. All the beekeepers use different sizes. These are 2 ways. They're split on either side. You can have 4 ways. They all use different type of mating boxes. I do a little bit of custom insemination in California. I take semen down there, and they provide virgins from the breeders they picked out from the year before that they like the best. They're catching some drones from some of the breeders here. These are drone cages. So it's a process. It takes a lot of planning and work to get that to work well. And tomorrow I'll talk a little bit more about the insemination procedure. A lot of that is really important is the care those queens are given to get them up to par. So basically that's in a nutshell, that's kind of the routine, the system I use. But again, it's just working with a population, trying to close it off in the sense that it's closed because I use instrumental insemination, but I'm always kind of looking around to see, are there other resources out there that I can use? When they wrote the theoretical model of the closed population system, Page and Laidlaw predicted maybe a 20-year life of this, and then you would start getting some inbreeding effects. Just the nature of it. Anytime you do breeding, it kind of narrows down the gene pool. So I started, I was really concerned about that because of the time of this. So we obtained a permit from the Department of Agriculture to import semen, honeybee semen. So I was really interested in bringing in semen from some of the native range of these bees. There's some other locations. So, and if you look at agriculture in general, a lot of the major gains in breeding has really been working with having access to other stocks like this. So plant and animal breeding programs, really based on genetic diversity. So we looked at that. And if you consider the U.S. population, honeybees are not native to the U.S. And in 1922, the Honeybee Act was put in place to avoid the introduction of tracheomites. And it was very successful in that. It took us till about 1984, 83, 84, before tracheomites were introduced, in the mid-80s. But if you look at the loss over time, when the tracheomites came through, there was a big loss of colonies initially. And that's followed by Varroa mite in the 90s, and then colony collapse disorder. So a lot of concern about, do we have enough diversity in our U.S. population? This is a survey by Washington State University. They took samples of all the queen producers and looked at the diversity within those. And over a 10-year period, from the mid-90s to about 2004-05, they found about a 25% loss in the alleles of those populations, which is just kind of a assessment of the diversity there. That's pretty scary. They also found a little bit of a gain. USDA imported Russian stock. We also brought in Australian package bees to answer the demand for pollination of almonds, because there was a lot of concern of the high loss of bees with CCD. Could we supply the bees needed for almond pollination? And of course, the Africanized bees. Not necessarily that she was invited in, but she's there. So, and then you have this in a survey. Since about 2006, we've had about a 30% loss of colonies in the US, and that's kind of continuing. So you see this kind of decline. So there was a big concern about genetic diversity in the US. And I was particularly concerned about my program. So you've got this small founding population confined by the 1922 Act. You've got the feral population pretty much eliminated with tracheomites and varroa mites. I think a lot of the commercial queen producers before this time, you just raise virgins, and there's always drones out there to mate with, and that really changed. There was a real concern. So, and I think that feral population kind of added to the gene pool. So that's a concern. And also the queen producers. We have a small number of queen producers in the US. They're producing there's about 1.5 million queens annually, and that was from about 400 or 500 different mother queens, and that's kind of a small gene pool. So there's another bottleneck effect in that. So you have these kind of genetic bottleneck effects over time. So a bit of a concern, and we know genetic diversity allows the population to adapt to these changes, to deal with new pests, parasites, whatever it is, change in the environment. So it's really critical, especially for bees, very sensitive to inbreeding. And we've hopped on this a lot, this lectures. But so we went to the USDA and sought permission to bring in germplasm. We limited that to germplasm because it's much safer than bringing in live bee stock queens. We know that viruses do travel in semen. So all the semen that we brought in was tested by the USDA for viruses, and then we would inseminate queens, local domestic stock, and that stock was put into a quarantine, and we would test the progeny and make sure we're not bringing in something unusual, something that would harm the industry. So, of course, my interest was Carnica. We went to the German Carnica Association and brought in some semen from them. And then we also went to Slovenia, where Carnica is native, and brought in some semen. What you're looking at there that's a tube of semen. It's amazing. You can hold this at room temperature with good success for about 10 days, 2 weeks. That's not possible with mammals. So that was a big advantage. These are some of the bee houses in Slovenia. It was really fun to see those bee houses. They're really fun. This is one of the apiaries we collected from in Slovenia. This is the most protective bee equipment I wore in that country the whole visit. That just shows you how gentle those bees were. They use these little pressed wood sticks. We had a smoker, but this was sufficient. Most of the beekeepers just have a pipe they smoke. There's a resident bear. These are little mating nooks. There's a resident bear that lives in this area. So they caged up the mating nooks so they would. This is a little bee house that you have the breeder stuck up here. We went up here and collected drones from these colonies. They're the breeding mothers. There's a little cabin down here. This is a little place up in the woods where they keep the bees and make them. A little place where you can spend the night, make a meal, and check the bees, visit with the bees. This was owned by 3 different queen producers. Some more shots of Slovenia. This country is very proud of their beekeeping. Long tradition of beekeeping. really interesting to see that. They love to paint these little plaques, and there's a lot of history in these, a lot of history and folkloric tales and all kinds of things in that. This is the inside of the bee house. You've probably seen these where you can just pull the frame out, and it's on these. The frames are concave and there's rollers on there, so they're not. You would think they would be sticky with wax and propolis, but they were very smooth, really easy to work with. And then I set up in a little corner here, set up my microscope, a syringe, a little flight box, and collected semen. And then we collected some more later. And this is his a little back at his house laboratory setup. Gave me a toast of mead. The beekeepers make a good living. They use all kinds of products. They had so many different products in the store, like you have down at the honey show. Very impressed, from baking goods, liqueurs, and wax products, and cosmetics, and all kinds of things. But really, really nice to see that. We also went to Republic of Georgia. The Caucasian honeybees were introduced in the U.S., but they weren't very well favored, probably because they make a lot of propolis, kind of messy. Beekeepers didn't like the way that all stuck together and the frames and stuff. But now we know that propolis is a self-medication. The bees collect it as a barrier against pathogens and diseases. So there's a lot more interest in this now, and I was quite curious about the Caucasian bees. So we went back to Georgia, and I only had Carnolians, so the semen, we mated those to Carnolian virgins and then back-crossed it a couple generations to make that more pure of the subspecies. This is a colony in my backyard. I have my screen bottoms on the hive, and this is just the bottom super. She didn't like the screen bottoms, so she just glued it all up. She just pasted those frames together with propolis on the bottom. I was like, whoa, pretty impressive, very impressive what they do. And again, we know this is a defensive mechanism against pathogens, diseases. Getting there was a little cumbersome. This is the road up to Mestia. We went into the high mountains near the Black Sea to collect these. We wanted to get the Caucasians as pure as possible. Pretty rough ride. We had a van full of liquid nitrogen tanks and microscopes and all this stuff to carry up there. So it was. This was the traffic. The animals seem to kind of like to hang out in the road, nice and warm here. You know, you have to kind of. It's funny. They would fence the gardens, and the animals were just outside and everywhere, roaming around. It was really cute. Sometimes you see them with like this long. This is so that long collar there, piece of wood, so that they don't go through the fence. Yeah, it was pretty. Yeah, and you'd have to stop and wait for them to move the cattle across the road. There was a lot of roadside beekeeping there. The roads were kind of rough, and they would put the hives off to the side. They bring them up here to the honey production. We were just driving along. This is a priest we saw out there. He was checking his hives, and we said, "Hey, can we look?" We noticed that on this was kind of late season for them, and you'd see the drones on the entrance of the colonies. They were starting to kick them out, so the timing was really critical. I was really happy to see the drones, but a couple days more, they would just disappear. And I noticed that. The Caucasians are very severe when they decide to kick the drones out. They do it within a few days. You've got the big pile of drones in front of the colony. When the season changes, the nights turn a little cool, the days are a little bit shorter, they're done. This is a drone collection up in this area. You can see some of the old ruins. These were towers. They used to shoot arrows at the Russians. Just some of the scenery. And here, this poor drone, we saw a lot of this, but the good thing about that is these old drones were a high rate of maturity, so that was really, really nice for us to collect them. This is a little clip I'm going to show you. On the back of my bee truck, I had an old screen bottom board, had a big chunk of the propolis here, and these Caucasians would just come up and recycle it. I was just really impressed with this. Watch this worker bee. She'll collect the propolis and pack it into her pollen basket. Watch that. Isn't that cool? Yeah, you would think this was candy. They were just really fastidious. And they finished that, so I went in the back and I got them a little mating nook that I had one of the queens in, and they finished all the propolis. That's just the entrance there of an empty box. I had moved her into a larger colony, so you can see they just totally cleaned that entrance up. This is going back to the original bottom board you saw earlier. They're digging underneath the screen here. They're just going for every little bit of propolis available. This is just, I walked around in the field and I was curious where they were. This is where they were putting it back in. This is just a regular hive. Bees coming home and filling up. I also had a bowl of wax back there, and the bees were also really fastidious and recycling that wax. This is this shows the impact of the germplasm that we did bring in. This is a graph showing we brought in Carnolian, Caucasian, also Italian Ligustica. So and we gave these breeders to the California queen producers to mass produce them to benefit the industry. So this is looking at the diversity of alleles in the population. This is the California population before we brought in germplasm. After we brought in germplasm, we resampled them, and this is the diversity, allelic diversity we found after we introduced some of the old world stocks from the importation. So you can see there's a big impact there. And a lot of beekeepers kind of noticed. They asked, oh, what did you do to the Carnolian population? I know it seems more vigorous, more productive, more. So there was kind of anecdotal reports that they were really appreciating that difference. We also during our travels, we also put some of the semen in the liquid nitrogen tank. At first I was a little leery about this because results were not so good. So this is Brandon Hopkins. He works with a cryopreservation. He was a grad student. He's now a doctor there. But he kind of perfected this to the point that it's practical. We can do this. But initially I was really skeptical. I would want the fresh semen to bring home. I wasn't too convinced that this would work, but it does. The viability is variable. You get from 60 to 90% viability, but it's enough to recover the stock, and that saves a lot of time and effort if I can just take a tube of semen out of that liquid nitrogen tank instead of traveling back to these faraway places, which is expensive and time consuming. And that also you can do selection, a lot of back crosses with this. So pretty exciting to have that kind of capability. This is Jacob from Poland. He came to visit me for a while. We do a little bee beards for fun at the end of the season, so that's kind of fun. So, and also I want to thank you to our sponsor, Thorne, for providing support for us to be here. So, do we have time for questions? Okay, that's kind of a nutshell my program, but it's, again, it's about, thank you. The secret here is just maintaining genetic diversity in your population, keeping the selection pressure on that over time. And it's going to change, it's going to be variable, it's going to be all over the place, but the longer you do that, the more consistency and uniformity you're going to do. And don't be afraid to experiment with something else on the other side, but be careful how you introduce that, because it will dilute out what you've selected for, but at the same time it gives you that vigor of the diversity. So again, it's kind of a balancing act. Questions?
In another century, literally, when you were at Ohio State, you had Cordovans. Have you still got Cordovans? And if you have, you'd like to tell us a little bit about them.
Oh, I have a funny story there. I had one of my students, he got pretty good at semen collection, and he would just seed that into my Carnolian population. And if you know what Cordovan is? It's a genetic mutation where it takes away the black body parts. It's recessive, which means you have to have it on both the queen side and the drone side to see the expression of it. We used it experimentally for different things. So I did maintain a small population of that. In the Carnolian, the color is kind of a purpley chocolate. It's really kind of pretty, but as I said, one of my students, he would just seed that a little bit in my gene pool. So you see that popping up even now occasionally, which is kind of fun and interesting. It doesn't mean much, except it's early on, before we had all the molecular tools that we do have now. We used it for genetic experiments as a marker to follow genes and things like that. So is anybody familiar with that? If you put this in Italian, it looks kind of a reddish blonde color, kind of pretty. We have, there's 2 commercial queen producers in California that raise Italian queens, and they really favor that. They call them the redheads. The neighboring beekeepers kind of complain about it because it kind of, but it was also part of the Starline 4-way hybrid. They use that as a marker in there sometimes, so you see it, it's pretty widely spread, you see it popping up a lot. But it's just a color mutation, but interesting question. So.
When you go from hive to hive, comparing and contrasting, how do you keep the records?
The record keeping is really important. Mine's really simple. I just have a simple Excel file, you know, and I give that 1 to 3 point for each of the traits. I should have flipped that up for you, sorry. And then you get a colony score. And then I have a rank for the yard, so I can rank I take the top few of each yard, and then those are the breeders. But the more simple you keep it, the more likely you're going to get through it and do it. So I used to do 1 to 5 for, say, something like temperament, runny, kind of 1 or 2 stings, 3 stings, and things like that. Just that chart. Now I go 1 to 3. The population's a little bit more uniform, and usually if she gets a 1, she's kind of on the outs. 3 as well. 2 is I'm not too sure yet. If she's a 3, okay, she's going to stay in the program. But it's the more simple you can make that. You need some kind of a selection index, something. So, just a number tag, something you can rate that colony on. Again, rather than checks and minuses on top of the lids that may get moved around, changed like that. So it's a very simple system.
Do you have, do you see it possible that here in the UK we could use germplasm importation the same as you are? Do we need to go that far?
You've got it here. I mean, this is where all the bees come from. And I think you have a pretty good diversity here. It depends what you want to do with that, but there's a lot of diversity here already. I think what you need to do first is just fine-tune the program, decide what you want to do. This is something you might want to do with mellifera, just to conserve that population. You could bring in mellifera from other places if the gene pool is too small. But it's really hard to advise you on that because, and I do it very hesitantly because there's a lot of pathogens out there, and especially viruses. Even if you bring in semen, you could be bringing in viruses, and there might be different variants of something that's going to be more detrimental. So, I'm getting more and more nervous about those importations. I think we're going to do one more trip, I think, this year, and it will probably be the last trip we make for this importation.
I haven't used Carnolian bees for decades. They were a wonderful bee, had all the character that you showed up there. But for me, very swarmy indeed. And as we do have a very high proportion of urban beekeepers in this country, you know, I do feel that is a characteristics that we want to keep away from.
Yeah, I hear that a lot, and I've seen that swarminess, especially it seems like the Australian Carnica is way more swarmy than the German Carnica. And I think in the past, it's the way they made increases is catching swarms, so you're kind of promoting that, or you're kind of selecting toward that, maybe in the old times. But the U.S. population is not as swarmy, but our bees are kind of Americanized. I don't have pure Carnica.
I don't know whether he's published it or not, but Giles Budge at the National Bee Unit did a lot of work, and he found genetically, which people have used both, behaviour characteristics are different between the Slovenian and the German Carnolian. Genetically, the markers are different, and presumably this is because of the intense selection pressure that the German breeders have put on it.
So which one was more swarmy? Do you know?
Yeah.
Which one was more swarmy?
I think, well, the Germans would say that those was, but definitely the Slovenians, because the Slovenians want swarms. You know, those little boxes that you saw.
Yeah, well, the bee houses are
count
pretty
on them,
confined
so,
and restricted.
But
so
I think part of their problem is congesting them. So you're not really comparing like with like.
yeah.
Unfortunately.
Well, the management is really key, and just I guess the way we run our bees, we're shaking bees and for nooks and pollination and all kinds of stuff. So maybe it's a different.
Just going on from that, made me wonder how many splits were you doing per colony per season? How swarmy they are.
Usually I start my season out with the ones that, the culls, I'll break those down and make them into nooks and requeen them. And once they build up, some of them, you keep some for drone mothers too. So the splits are mostly made out of the culls. But I'm always out of those breeders, once we've decided, I'm taking brood for cell builders and different things like that. So they never get really huge and big. And I just don't see a lot of swarm cells in there.
With the sperm in liquid nitrogen, do you use a cryoprotectant, or is it just...
Yes.
Yeah, you do.
Yes. Yeah.
Okay.
Yeah, that's really important. It's... I'll talk about it a little bit more tomorrow. It's a process. I mean, Brandon's kind of fine-tuned the diluent we used, also the cryoprotect, and the freezing. The freezing and thawing is the most critical, because you don't want ice crystals to form. The duration of the time in there is not important. It's the process. So he's got it all computerized, timing. He takes it down to I think -4, and then it goes down to liquid nitrogen. I think one of the secrets was. Moving the liquid nitrogen as you dunk it, because it'll freeze faster. So there's a lot of little things in there.
You don't have gaseous.
I'm not completely familiar with that whole process. I've watched it, but he's written a bunch of papers, and I can, if you really want that information, I can get it for you.
Okay. Yeah. And the second question was, when you're introducing this new germplasm. You're getting, I imagine, a certain amount of hybrid vigor just from the fact that you're crossing, and how much does that carry through to subsequent generations?
That's a good question. Yeah, it seems to, I mean, that first cross was absolutely amazing. That it went from little 5-frame nooks to, this was a good season, a good yard, but there were like 5 boxes, deep boxes, plugged. And I was traveling, I had somebody check it, I said, why is all that equipment piled on there? But they just did such a job. Really exciting. But I do see that the bees are productive and vigorous. You may not see that degree of it, but it's variable between colonies too. So it depends on, I don't know how much is the environment, how much is the honey flow conditions versus other things. But when I brought that germplasm in and crossed it and gave it to the queen producers, their customers noticed, hey, that's a little bit different, that's a little bit, you know, more productive. So
We have something similar here with the buckfast bees.
Yeah, the buckfast bee is a good...
Basically, it's hybrid vigor because each time you had to bring in
Yeah, well,
fresh,
that's a perfect
stock
example of
yeah,
a lot of
maintain
times
it.
when you cross things with between the subspecies, you'll get more defensiveness, but I think what Brother Adam had was an incredible ability to combine these different subspecies and get something good. But it takes a lot of work and observation to find those right places. But, you know, you have a lot of different things going on there.